Okay, so we're starting out with trying to convert 13, which is a base 10 number, into a binary number, right? And if it was a little bit confusing for you, basically the idea is here that we're going to come up with numbers that represent values in binary, place values in binary that go into this number. Okay, so we're going to say binary values have a 1's place, a 2's place, a 4's place, an 8's place, a 16's place, and we'll keep going up if we need to keep going up. Okay, so 13 doesn't have any 16's in it, does have an 8 in it, does have a 4 in it, doesn't have a 2 in it, does have a 1 in it. Okay, so that's one way of thinking about it. Another way of thinking about it is what's called the subtraction method. Okay, so we're going to look at the subtraction method right here. We're going to basically say 13 is my number that I'm starting with, and I'm going to subtract a value from it. Okay, the value that I'm going to subtract from it is going to be one of these values. 16 is too big to be subtracted from 13. Let's just pretend that we don't want negative values. Okay, so I'm going to subtract 8 from it, and that gives me 5. Because I subtracted 8 from it, that means that 8 goes into it, so I'm going to put a 1 there. Then 5 becomes my new number, and I'm going to subtract 4 from it. Since 4 goes into it, right, I'm going to put a 1 there. 5 minus 4 is 1. 1 becomes my new number. I'd kind of like to subtract 2 from it, but 2 is too big, so I put a 0 there to say that 2 doesn't go into it. And then I go to the next number down here, which is 1, subtract 1 from it, I get 0, okay? 0 is my new number. I put a 1 here because 1 did go into my number, and when I get to 0 and I'm down to the 1's digit, I'm all done. Okay? So let's do one more example. Let's do 35. Okay, so 35 base 10. We know that we're going to have a certain number of bits that's going to go into. Okay, maybe we're not sure how many bits it goes into, so let's just put a bunch of them. Okay, and I'm going to say that there's a 1's place, a 2's place, a 4's place, an 8's place, a 16's place, right? A 32's place, a 64's place, and a 128's place. Do I need a 128's place?
No.
No, I don't need a 128's place because 35 isn't that big. So I can either put a 0 there or I can just ignore it totally. Just say I'm not going to use that. Okay? 64 would be a 0 or ignore it totally. Am I going to use a 32?
Mm-hmm.
Yep. So I'm going to take 35 and I'm going to subtract 32 from it. That gives me 3, and because I subtracted 32, or because there was a 32 in the 35, I'm going to mark a 1 down. 3 is my new number. Does 16 go into that?
Mm-hmm.
No, so I put a 0. Does 8 go into it? No, so I put a 0. What's going to be in the 4's place? A 0. 2 does go into it, so I'm going to subtract 2. That gives me a 1. 2 goes into that number. Okay, 1 is my new number. Subtract 1 from it, I get to 0. Put a 1 in that place because 1 goes into it. All right, and now I have 0 as my new number, and I'm down to my 1's column, so I know I'm done with that problem. So 1 0 0 0 1 1 would be the binary value 35. Is that making sense? Okay, so guys, the way that we'd want to write that, if I was answering this on like a test or something, 13 base 10 equals 1101 base 2. That's how I show that I'm in binary. So write your answer down here for 35. So what you should have just done is 35 base 10 equals 100011 base 2. Is this making sense so far? Okay, so what I'm going to do is we're going to write together the algorithm for what we just did. Okay, so we're going to write the steps so that somebody else who just walked in here could just follow the algorithm and learn the process on their own. All right, so that's kind of difficult, but then I'm going to show you a different way of doing this conversion, and you guys are going to have to write your own algorithm. Okay, so let's write the algorithm to start out with. Let's first define some things that we're talking about. Okay, so the first thing that we're going to do is we're going to call this number. Okay, so that's the number that I'm trying to convert. Okay, the other thing that we have to define is these things down here. Okay, so can anybody come up with a good descriptive term for those values? What do you notice about those? The ones down here. So 1, 2, 4, 8, 16, 32, 64, 128. Okay, so they're place values, but how do you know, like, what's the values? How do you know what they should be? Start at 1 and then you double them. Okay, good. So that's how we can figure it out. 1 times 2 is 2, times 2 is 4, times 2 is 8. Yep, for sure. Anybody have a mathematical term for what those are? Okay, so super math nerds would call those things powers of 2. This is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So we get all of those numbers, right, by keeping track of powers of 2. All right. So those are the powers of 2. And then the last thing that we got to kind of define here is, so this is our number, okay? This is a power of 2. Right? What would we call this number? So if I'm doing 35 minus 32, what do I call the number 3? Right, I want to give that thing a name. Okay, so remainder might be a good name for it. All right, but remainder is usually, when you think about remainder, you think about what? Division. Okay. When you think about taking two numbers and you say, like, what if it was 7 plus 15? Then we would say that this is the sum, right? What do we call this when we're doing subtraction? If we're doing multiplication, we call this the product, right? Now I'm giving you everything but the answer, right? So now you can only think about sum and product. And difference, very good. So we're going to call that value the difference. Okay, and if you guys want to make a connection to programming, what we're doing right now is defining the variables that we need, right? We're defining, we need a difference variable, we need a power of 2 variable, and we need a number variable. Okay, so now let's take that and let's define our subtraction method. Okay, so step 1 for the subtraction method. We're going to assume that we're given a number here. We're going to find the biggest power of 2 that is smaller than the number. Okay? So find the biggest, that's where we're going to start with. The biggest power of 2 that's smaller that's smaller than the number. Sorry, that kind of got shrunk down there. Okay? Step 2, we're going to subtract the power from the number. Step 3, we're going to record a 1 in the binary value. Okay? And then step 4, we're going to reset the number to the difference in step 2. Okay? So just looking at this example here, all right, we had 35 minus 32, right? We didn't use 64 because 64 was greater than 35. So 32 is the biggest power of 2 that's smaller than 35. Okay? We subtracted the power from the number. We got 3. We recorded a 1 in the binary number. Okay? And then we reset the number, so underneath 35, we wrote 3, saying that that's the new number that we want. Is that making sense so far? Okay? So then, the next thing that I want to do is I want to figure out which number I should be subtracting from my number next. Okay? And basically the way that we do that is we're going to go down the line. We're going to say, okay, we started with 32. The next thing that I would like to subtract is 16. So how do I get from 32 to 16, and then from 16 to 8, and then 8 to 4? We divide by 2. Okay? So I'm going to go step 5. Reset the power of 2 by dividing it by 2. Sorry, that went off the screen there. Okay, so that's taking 32 divided by 2, I get 16. Okay. What do I want to do when in this example when I get to 16? Okay, so see if I want to subtract it from the number. Why don't I want to subtract it from the number here? Why didn't I do 3 minus 16? It would have been negative, right? So I don't want to be negative because my whole process is done when I get to 0, right? So I don't want to be negative. So what tells me that that subtraction or that difference is going to be negative? How do you know that? How do you know that this is going to be negative? Because the 3 is smaller than the 16, right? So step 6, we got to make a decision. Okay? So we're going to say if, like you just said, the 3 was smaller than the 16, right? So if the number, right, is less than the power of 2, what do I do then? So what did I do with my 16? When I got to here and I was like, okay, I'm not going to do 3 minus 16. What did I do instead? Put a 0, right? So if the number is less than the power of 2, record a 0 in the binary value. Right? And then I'm going to do a little trick here. I'm going to say go to step 5. Okay? So go to step 5 would bring me back up to here to reset the power of 2 by dividing it by 2. So I just used 16. Now I'm going to divide it by 2. I get 8. After step 5, I go to step 6. If the number is less than power of 2. Okay? Well, 3 is less than 8. You following that? 3 is less than 8. So record a 0 in the binary value. Put a 0 up here. Go to step 5. Go up to step 5. Reset the power of 2 by dividing it by 2. 8 divided by 2 is 4. If the number, which is 3, is less than the power of 2, which is 4, that's true. Record a 0 in the binary value. That's my 0 right there. Go to step 5. Reset the power of 2 by dividing it by 2. 4 divided by 2 is 2. If the number is less than the power of 2, is 3 less than 2? No, right? So what do I want to do now? Okay? So that's kind of like saying else, right? So the number is not less than the power of 2. Where do I want to go? Go to step 2. Okay? So right now the power of 2 is 2. If I go to step 2, subtract the power from the number. That's up here. 3 minus 2 is 1. Record a 1 in the binary value. That's a 1. Okay? Reset the number to the difference in step 2. That's where I got my 1 right here. Reset the power of 2 by dividing it by 2. 2 divided by 2 is 1. If the number is less than the power of 2, is the number less than the power of 2? Is 1 less than 1? No, right? It's not less than. Else, go to step 2. Subtract the power from the number. 1 minus 1 is 0. Record a 1 in the binary value. That's my 1 right there. Reset the number to the difference in step 2. That's 0. Okay, now let's keep going. Reset the power of 2 by dividing it by 2. Okay, the power of 2 right now is 1. Divided by 2 is 1/2. Okay, if the number is less than the power of 2, is 0 less than 1/2? No. Do I want to do this with 1/2? No. So what should I say? I got to add something to my algorithm here. I got to figure out when things should be done. Okay, so when the number is 0, we want to stop. Where should I put that command? Where should I put that step? Okay, so one thing we could do is we could make another else in step 6. We could say like, else if do this, else do something else, you know? I think that we can fit it in between 2 steps that we already have though. Okay, so I think if you put it after step 4, when we reset the number, once the number gets to 0, we could be done. Does that make sense? So in other words, if the number is 0 after step 4, we don't want to go to step 5. We don't want to reset the power and make another decision. We just know that it's 0, so we're done. Okay? So reset the number to the difference in step 2. And this isn't like the best set of directions here, but let's just put in here kind of 4.1, if number is 0, okay, stop. All right, so what I would like you to do right now, okay, is try to follow this algorithm, but do it for the number 12, okay? So I want to kind of leave this up here. What happens when you follow this algorithm, okay? Follow it just like a computer would, but for the number 12. Okay, so this is a difficult thing, okay, because you know the process and you know the you know how to get the right answer. It's hard to just follow the steps, okay, and find, like, maybe we screwed up, okay, and it turns out that we kind of did screw up. So let's take a look. Step 1, find the biggest power of 2 that's smaller than the number. Okay? So what's that? 8. Okay? Subtract the power from the number. So we're going to go 12 minus 8. That gives me 4. Record a 1 in the binary value. So I'm going to say this is base 10. This is going to be my binary value. I've got a 1 there. Reset the number to the difference in step 2. So I'm going to just write a 4 there. If the number is 0, it's not. Reset the power of 2 by dividing it by 2. Okay, so 8 divided by 2 is 4. If the number is less than the power of 2, is 4 less than 4? No. Record a 0 in the binary value, so it wasn't, so else go to step 2. So I'm going to step 2, subtract the power from the number. 4 minus 4 is 0. Record a 1 in the binary value, 1. Reset the number to the difference in step 2, 0. If the number is 0, stop. Okay, stop. So if I just follow these steps, I'm going to get 12 base 10 equals 1, 1 base 2. Is that true? Well, no, it's not true, right? We know that that's wrong. So there's something wrong with my algorithm. What's wrong with my algorithm?
It didn't tell us to fill in the
Okay, so it didn't tell me to fill in the remaining zeros, right? There should be 2 zeros here. There should be 1, 1, 0, 0. So I stopped too early. When should I stop? So it's true that I want the number to be 0 when I stop, right? But I should be filling in a 0 for when the power of 2 is 2 and a 0 for when the power of 2 is 1. Does that make sense? So when should I really stop? Okay, when the power of 2 is 1. All right? So inside of here I want to say if the number is 0 and the power of 2 is 1, then stop. Okay? If I had done that for this other one, then I would have said reset the power of 2 by dividing it by 2. That would give me 2. If the number is less than the power of 2, 0 is less than 2, record a 0 in the binary value. 0. Go to step 5. Reset the power of 2 by dividing it by 2. 2 divided by 1 is 1. If the number is less than the power of 2, record a 0 in the binary value. Okay? Put a 0. Go to step 5. Step 5, reset the power of 2. Oh, crap. I really want this if number is 0 and the power of 2, right, is 1. I really should do that after step 5. Does that make sense? Because otherwise I'm in this loop right here. This goes to here, and I never get to this stop. Okay? This goes to here. Okay? And I never get to that stop if I get to this situation. All right? So part of this was getting you guys to see this subtraction method, but part of it was also getting you to kind of see that writing out the algorithm is sometimes difficult, which you guys know, right? So it kind of turns into a bit of a gobbledygook here, but hopefully you can kind of follow those 6 to 7 steps. All right, you kind of know the process. There's one other little piece that we kind of screwed up here, and that's this. What if I do another example where you're trying to convert 32 to binary? Okay. What should I do in step 1 to make this a little bit better? Yeah. What do you think, Colin? Smaller than or equal to, okay? So find the biggest power of 2 that's smaller than or equal to the number. Okay? So writing these little algorithms can be a little bit difficult, okay? All right, so let me show you the other algorithm. Ready? This algorithm is called the division method. Bless you. I'm just going to show this one to you. Okay? We're going to take a number like 77. Okay? Now, just like we did the last one, I'm going to define some things for you. If I take 77 and I divide it by 2, what do I get?
36, no, 30. Yeah. No.
2 goes into 7 3 times with 1 left over, right? 2 goes into 17 how many times? 8 times with 1 left over. So I'm going to get 38 remainder 1. Okay? So let's define these terms. This last one is the easy one. What is that number? We just said it. Remainder. Okay? This is the one that we had trouble with when we were trying to find the difference, so let's come back to that one. This one over here, this is the dividend. Remember that? What is the 2 in this case? You guys remember that? Divisor? And what is this? The quotient. Very good. Okay? So you'll have to use those terms, right? You have to use those terms when you write your algorithm. But let's go through the process here, okay? So we're going to write this division, 77 divided by 2 equals 38 remainder 1, but we're going to write it in a different format, and I'll show you why, okay? You really got to watch what I'm doing here, okay? So we're going to take 77, and you guys remember doing long division. We're going to do long division, but we're going to flip it upside down, okay? We're going to divide 77 by 2, and we just said that that gives me 38 remainder 1. Okay? Now the reason I'm flipping it upside down, if you look up here, is because I'm going to keep doing that division process. I'm going to divide 38 by 2. Okay? 38 divided by 2 gives me 19 remainder 0. Okay? Then I'm going to do it again. 19 divided by 2 gives me 9 remainder 1. Does that make sense so far? You just keep on dividing by 2, okay? So I'm going to divide by 2 again. 9 divided by 2 is 4, remainder 1. Divide this by 2. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. 1 divided by 2 is 0, remainder 1. I know I'm done when I get to 0. Okay? These values over here are my binary number. Okay? It goes from bottom to top, left to right. So 77 base 10 equals 1001101 base 2. Okay, so that's a little bit of a different process. Why don't you guys try to do that process with a different number here? Let's use 100. Okay, so 100 base 10, what does that equal in binary? Go ahead and try to do that on your own with the division method. Okay, so let's do this together here. We're starting out with 100. As I'm kind of checking what you guys are doing, going through here, we're going to go 2 goes into 100 50 times, remainder 0. Okay, so you should not have a remainder on the 100 line. You should have a remainder after you do your first division. Does that make sense? So then we're going to go 2 goes into 50 25 times, remainder 0. 2 goes into 25 12 times, remainder 1. 2 goes into 12 6 times, remainder 0. 2 goes into 6 3 times, remainder 0. 2 goes into 3 1 time, remainder 1. 2 goes into 1 0 times, remainder 1. Okay? And then again, this is your left, this is your right. Okay? So we're going to say 100 base 10 equals 1100100 base 2. Okay? All right, let me give you a quick way of checking your work. All right? I'll answer your question in a second, but let me just give everybody a quick way of checking your work. So let's go back to this one. We said 77 is 1001101. Okay? We're going to say this is how many 1s, 2s, 4s, 8s, 16s, 32s, and 64s I have. Does that make sense? So 1's place, 2's place, 4's place, all the way up to the 64's place. I have 164, so 64 plus 1 8, so that plus an 8, plus 1 4, plus 1. 64 plus 8 is 72, plus 4 is 76, plus 1 is 77. So I'm just checking my work there, okay? Check your work for the 100.